All right, question number 20. It says the following classical curve has been studied by generations of mathematicians, used for analytical methods, including implicit differentiation, graphing utility to graph the curve. Wants me to use, I'm sorry, not using. Include as much detail as possible. So with this one, it looks similar to a unit circle, which is a radius 1. I would just use graphing utility. You could plot points, but whatever you plug in, these two values are going to equal 1. So I would assume A or B, probably B because it says an asteroid type shape. But if we're going to graph it, we need to solve for Y. And let's see if we can see that shape. All right, so I'm going to subtract this term. And then I'm going to raise it to the 2/3 power, or raise to the third 3/2 to get rid of that power. So I'm going to graph y equals this expression. We're going to go parenthesis 1 minus x. We're going to raise that to the 2/3 power. And then we're going to raise this to the 3/2 power. 3/2. All right, let's see if we can graph. Okay, so when we zoom in on that, okay, it's missing out on the negative sections, because when you both get negative, you can get ones. Negative times a negative, so I would assume it would also include these. See, it doesn't like that, because whenever you do the square root, you got to consider positive or negative, and the calculator doesn't do that, so you have to do that by hand. And the way I would get that to show up is doing the same thing, but doing a negative one because of that square root. But I'll show that here as well. It's 1 minus x. And then we're going to raise it to the 3/2. So the calculator doesn't get that second one. You would have to understand that when you're doing this square root, 2 on the bottom, you get plus or minus. So if I graph it now, it does that line, and you see the whole shape. So A is the one that you want. You just got to be careful when you're solving it by hand.